This video today is going to be a crash course on LlamaIndex, which is an agentic framework for Python similar to LangChain, but I would say it has a stronger focus on retrieval, on RAG, on retrieving context, on parsing different data sources, connecting to different data sources. I would say that for the most part you can do with LangChain what you can do with LlamaIndex and vice versa, but LangChain is more general and LlamaIndex is more focused on, as I said, advanced retrieval techniques. And we're going to talk about that a little bit, but mainly this video today is going to be a beginner-friendly introduction to LlamaIndex. So we're not going to go into the very deep, low-level advanced retrieval techniques. I'm going to maybe mention them in the end, but primarily this crash course today is for giving you an introduction into LlamaIndex. So you know how to build agents, how to do function calling, how to do basic RAG, how to connect different data sources, vector stores, embedding models, and so on, how to work with LlamaIndex on a basic level. If this video performs well, I'm going to go deeper into it as well. If you like this video, let me know by hitting a like button and subscribing. But now let us get right into it. Alright, so we're going to do a crash course on LlamaIndex today, which is, as I already mentioned in the introduction, an AI agent framework for Python, similar to LangChain, for example. Which already brings me to the first thing I want to briefly cover, the question, should you be using LangChain or should you be using LlamaIndex? And I want to keep it short here, so my answer is whenever you're comparing frameworks, unless one of the frameworks is obviously inferior in most aspects, you should probably try both, see the pros and cons, maybe even learn both, so you have multiple tools in your arsenal, in your toolkit, and then pick the one for the respective use case. So if you're doing something very RAG heavy, something that's focused a lot on retrieval, on indexing, on dealing with different data connectors, then LlamaIndex usually, rule of thumb, is the better choice. If you're doing something more general and end-to-end, then LangChain is usually the go-to framework. Besides that, of course, you can also have preferences in terms of the code base. People say that the LlamaIndex code base is very clean. The LangChain code base is not so clean. I don't really have an opinion on that. I didn't really look into the code behind the scenes. But in general, my opinion is always try to learn both. Same thing with PyTorch and TensorFlow. Yes, PyTorch nowadays is the more popular, more commonly used framework, but I think it's good to know both technologies, frameworks, whatever. So I would recommend learning LlamaIndex in general, and especially if you're interested in doing something focused on retrieval, data, and data connectors. That's enough talking now. Let us get started with the environment setup. For this, I'm going to navigate to my tutorial directory in the terminal. And I personally like to use UV as a package manager, so I'm going to do that. If you just want to use your Python installation, feel free to do whatever I do with UV on your basic Python installation. So just do pip or pip3 install, and then the packages that we're going to need today. In my case, I'm going to do UV init to create a UV project, and then I'm going to say UV add instead of pip install. Same effect, just that I have this Rust-based package manager and I have the isolated environment. Don't have to do that if you don't want to, but the packages that you're going to need, whether you install them with UV add or pip install, are of course LlamaIndex, and we're going to also need python-.env and Jupyter Lab. So why do we need these packages? LlamaIndex for obvious reasons. Python.env to load environment variables from a so-called .env file, because we need an API key to interact with large language models. And then we're also going to use Jupyter Lab as our coding environment. Besides that, I think I don't have anything in the code that I prepared that needs external packages. What I would also recommend, if you want to follow along with every aspect of this tutorial, is to have Ollama on your system. Ollama is basically allowing you to host large language models on your system. So in my case, if I do Ollama list, actually I need to first do Ollama surf. But when I then do Ollama list, you can see I have this Qwen3 model with 0.6 billion parameters. That's just something I'm going to be using in LlamaIndex. If you want to also do that, get Ollama on your system and pull some model that can run on your hardware. After that, we're going to go back into our tutorial directory, and here you need to create a so-called .env file. In my case, I already have this file. Actually, I need to run LL so you can see it. This is a file called .env, so literally just dot and then env. I'm not going to open it because it contains an API key. I'm going to create a second file here. I'm going to call this .env demo, but call your file that you're creating .env. Here, what you want to do is you want to say OpenAI_API_key equals, and then the API key. Where do you get it? You get it from OpenAI. So you go to your OpenAI account, you go to settings, API keys, and hopefully you have a better naming scheme than me. I just literally, every time I create a key, I just smash on my keyboard and I get some name. But you just get the key, you copy it, you paste it into your file here, into your .env file, and that is going to be loaded in Python. So what we're going to do now is we're going to run JupyterLab, which is an interactive Python notebook environment. So if you just use your Python installation, you run JupyterLab like this. If you're using UV like me, you have to say UV run JupyterLab. And once you have this opened up, it's going to open up a browser tab. I'm going to move the terminal to a different workspace. And here now we have JupyterLab. So this is an environment for working with interactive Python notebooks. We can create one by clicking on this button here. And I always like to give an introduction here. If you've never used an interactive Python notebook, the idea is you don't just have a Python file that you run every time from top to bottom. You have individual cells and you can just set some variable here, for example, use it in another cell. Then you can reset the variable down here. You can go up and run this code. It changes. You can also have multiple instructions per cell. And the main reason to use a notebook like this is just because when you're doing data science, machine learning stuff, especially when training models, doing data analysis, it doesn't make sense to run every single thing from top to bottom. You want to run maybe one additional visualization, but you don't want to load the whole data set from scratch again. In terms of working with agents, it's not a necessity. You can also just play around with Python files. But for learning purposes, I like to use Jupyter notebooks because we can run individual cells and that's quite flexible. So the first thing we want to do here is a basic example of getting data from a very simple data source. So what I have here in the file tree is I have two directories, data and data2. These just contain text files. So these 5 text files here, file1.txt up to file5.txt, contain very basic information. I love Linux. I think Apple is better than Microsoft. I think bananas are better than apples. I like oranges. Programming is fun. So these are opinions that I have, for example. And what I want to do now is I want to just take this directory with LlamaIndex, turn it into a data source, and then query using a query engine and get answers to questions based on this directory as a data source. So that's going to be our first basic example, and then we're going to take it from there and add more stuff as we go on. The first thing we want to do is we want to load the OpenAI API key, so the environment variable. For that, I'm going to say from .env import load.env. Then I also want to call load.env. So if you named the key correctly, now the OpenAI API key is going to be in the environment, and LlamaIndex and the OpenAI tools are going to automatically recognize that and connect to your account, which of course means that you're also going to be charged for it, even though it's not a lot. That is how it works here. And the basic example now is we say from LlamaIndex .core import vector store index and simple directory reader. So a vector store, for those of you who don't know what it is, in a very basic way, an embedding is a point in vector space. So let's say you have 2 dimensions, then you have X and Y. If you have 3 dimensions, you also have Z. If you have 1,000 dimensions, it's hard to visualize, but you have a point in n-dimensional space produced by an intelligent embedding model. And these placements of the points make sense because they're close to one another if they're semantically similar, and further apart if they're not. So if I have Apple, the company, it's going to be closer in this embedding space to something like Microsoft, even though they're different companies, but it's going to be closer to that than to the concept of a banana. Even though the banana is a fruit and apple is also a fruit, but this apple here with a capital A, if it's a company in the sentence, for example, it's clear that this is a company. It's going to be further away from the fruit stuff and very close to business stuff and tech stuff. That is the basic idea. And the vector store now is a database that contains these embeddings. That's the in a nutshell explanation here. So what we're going to do is we're going to say the documents that we're interested in are simple directory reader data load data. That is going to load these files as documents, and then we can create a vector store based on that. So we can say index is equal to vector store index from, where's my autocomplete, from documents. That is super simple. Now, what can we do in order to get information based on that? Here you can see we did a call to OpenAI embeddings. What does this mean? I have the documents, but the documents are not embeddings. They're not points in vector space. So what this OpenAI call does is it uses the embedding model of OpenAI to say that I want to have the vector representation, the embedding representation of these informations, of these pieces of information, and then they're taken into the vector store. The results are taken into the vector store. And now I can create a so-called query engine, and I can say index.as query engine. And then I can just say here query engine dot query, and I can ask a question. For example, the question could be something like, do I like Linux? Question mark. And the response is going to be a pretty big object, so we can just print it. By printing it, we turn it into a simple string answer, you like Linux. Now, maybe I can say also, what is my favorite fruit? And then the answer is going to be oranges. So as you can see, it took the information that there's a file in here. I don't know which one it was. File 4, I like oranges. It took that as context, and now it knows I like oranges. Now, I didn't say that it's my favorite fruit, but it's close enough. So that is a very, very simple example of how to turn a collection of text files into a vector store that you can then query. So if you have just a directory full of text files, you can just turn them into documents, turn them into an index, and then you have a query engine to interact with that. That is a super simple use case. Now, what I want to show you next is how we can build basic agents. Basic agents in terms of like how we can do it with LangChain. You have an agent. This agent is based on a certain large language model. Maybe let me get rid of all this here. Based on a certain large language model, and this large language model is the thing interacting with you, but maybe you also have functions, maybe you also have some context, some system prompt. So that is the idea of an agent. How do we do that in LlamaIndex? For that, I'm going to say here from LlamaIndex.core.agent.workflow, import the function agent, and then from LlamaIndex.LLMs.OpenAI, import OpenAI, because we're going to use an OpenAI model. Now, for this function agent, I can provide a tool that this agent can use. For example, let's say I have a function. Let's just make a very simple one, get favorite color, which is going to get my favorite color, and I'm going to use something that is probably not going to be guessed by a LLM in general. So if I ask it what's my favorite color, it might say blue because that's a common response. So I'm going to say here cyan. So I know it's actually coming from the function and not just a random guess. And now I can create an agent that has access to this function to answer questions if it doesn't know the answer. So what I can do now is I can say agent is equal to function agent. And the first thing I want to specify here is the model that this agent is using. So I can say LLM is equal to OpenAI, and in here now I can provide the model name. So I can say model that I want to be using is, for example, GPT-40-mini. And actually I need an additional dash here. So GPT-40-mini. Now, in addition to that, I can use certain tools. So I can say tools is equal to, and I can just pass a list of functions. Get favorite color, for example. And then finally, I can also pass a system prompt, and that system prompt is just going to be, you are a helpful assistant. Let's see if that's enough to make it answer the question what my favorite color is. But that is very similar to what you would do in something like LangChain. You just define the agent, you set the model, you set the tools, you set the system prompt, and then you use it. Quite simple, quite straightforward. So in order to now get a response, I can say response is equal to, I have to await the answer. So I can say await because that's asynchronous. Otherwise, I'm just going to get a response object promising me a future answer. But I have to say await agent run, and then whatever my question is. For example, what is my favorite color? Question mark. And this now is going to take some time. So it posts here to ChatGPT. You can see I get completions, and the result is of course print response. Your favorite color is cyan. So we can also see here 2 function calls or 2 to completion calls. I guess the first one is something like that is being asked. I have access to these tools. What should I do? Then the response is, okay, the response is cyan. I called the function. This is the response. And then the model tells you your favorite color is cyan. So it's like 2 iterations here. That is a very basic way to use agents in LlamaIndex. What you will notice, however, is that now I cannot just continue the conversation. I cannot just say here response is equal to await agent run. And I cannot just say, is this common for people? Question mark. Because if I do that, it doesn't know what I'm talking about. I can just run this and I will get a response. So I will get something that I can print here. Could you please clarify what specific behavior situation you're referring to? Because it doesn't have any context. It doesn't know that we talked about my favorite color. If I want to change that, I can go and say from LlamaIndex.core.workflow import context. Then down here, I can say ctx is equal to context of agent. And then when I do something like agent run, I can say ctx is equal to ctx. So I can just run this. I will get my answer, same as before. And now I can say here ctx is equal to ctx. And just by doing this, I introduced context, and now it knows that cyan is a vibrant and appealing color, and popularity can vary amongst individuals. So as you can see, this is super easy, and now it has the context, it has the message history. So now let's combine the 2 things we learned about and add a tool that allows us to access the data here. So let's say now we have maybe a function called get context from database or something like this. Probably not the best way to phrase this. And above that here, I'm going to define again that I have the vector store. So we're going to do the same thing that we did before. Documents is equal to, what was the actual, I need to also import this from LlamaIndex.core import simple directory reader and vector store index. We're just going to say again, simple directory reader. Repetition is key if you want to learn something. Load data. And then we're going to say index is equal to vector store index dot from documents. And then we need a query engine. The query engine is going to be equal to index as query engine. So we're going to use this now as part of a tool that can get information from the database. So we can do something like return, and then maybe the string response here of query engine dot query. And that is going to be, the question has to be passed here. So we can say question, or let's say query is going to be passed here. Or actually, I think it makes more sense to say response. Let's make this asynchronous. Let's say async def, and then response is equal to await. And we're going to do query engine dot a query for asynchronous query. And it also makes sense to provide type hints, not for us, not because we're writing clean code, but because the model can then know what it has to pass to this function. And then we're just going to say return string of response. So now we have the same thing that we did before, documents, index, query engine, but we're using this in a function, an asynchronous function here. We're using a query, not query. We're awaiting it, and we're returning the response. We're doing string response because otherwise we're going to get this huge JSON object. This way we just get the raw answer. And now we can just pass this here as a tool. We can say get context from database. I'm not sure if that's going to be enough to answer some of the questions here, but we can try down here directly by saying response is equal to agent.run. And our question is going to be, what is my favorite food? Question mark. Maybe it needs some help to answer that. I think so, actually, because, yeah, I don't have access to your personal preferences. So let's maybe say in the system prompt, if you don't have, we're now not going to care about, or let's say do not. Okay. If you do not have access to information needed for the answer, consult the tool query from database. Is that what it's called? Get context from database, actually, sorry. Get context from database. So that should be fine. Let's go and run this again. Let's go down here and see if it can handle this Yeah, now you can see completions, embeddings, completions, completions. So what most likely happened is it got the request. Oh, I don't know the answer. I need to call a tool. Call the tool, do the embedding of this question. Then you get a response, and then you get the final response. So that is here the querying, and that is the final response that we're getting. And the response is your favorite food is oranges. So that is now rack capability in our agent. By the way, what we can also do now is we can go back. I can create a new notebook that's unrelated to this one, just for testing here. And here now I can load the vector store when I export it here first. So I can say index.storagecontext.persist. And I can say storage, for example. That is going to write it into a directory called storage here. And then I can go into this new notebook that is unrelated, doesn't have access to index here, as you can see. And I can just say from LlamaIndex.core import storage and load index from storage. Actually, sorry, it's storage context, not storage. Then I can say storage context is equal to storage context from defaults, and we're going to provide here storage as a keyword argument. Persist directory is equal to storage, and then I can just say index is equal to load index from storage, storage context, and finally query engine, that is the same as before, is equal to index as query engine. That, of course, doesn't work because I don't have the OpenAI key, so let me also do a quick from .env import load.env. That is going to load the environment key, and now I can rerun this. And this will get our vector store, and now I can just say query engine, and I can ask again, same way I did before, what is my favorite fruit, question mark, and then that's going to be, str of that, oranges. There you go. Now let me show you briefly how we can do the same thing with local LLMs. That is actually the same process. The only thing we need to change is we're not using OpenAI, we're actually using Ollama. But this also brings us now to a second part, which is LlamaHub. And this is the rich variety of data connectors that we have for LlamaIndex. So whenever you need something for LlamaIndex, you can go to LlamaHub AI and you can find or you can look for specific embedding models, specific vector stores. In our case now, we're using Ollama, so I can just type Ollama. We can see here, oh, there you go, Ollama, and it says I have to say pip install LlamaIndex LLMs Ollama to be able to connect to my local Ollama models. If you don't know what Ollama is, it's this nice tool here. You can go to models to see what kind of models are available. I would recommend, if you don't have very powerful hardware, you go with a very small model. I think, as I said, I'm using Qwen 3, 0.6 billion parameters. All you have to do to use these models is you have to open up a terminal. You have to do Ollama serve once you have installed it, of course. I'm not going to go through the installation process. And then you have to do Ollama run or just Ollama pull if you just want to have it on your system. And in my case, I already have it, but you would pull, for example, Qwen 3, 0.6 billion. And if you have this, you can just use it in your program. You can also just use it by chatting with it in the terminal. So I'm going to close this one. I'm going to move this somewhere else. And we need, as I said, this Ollama integration. And as I also said, you can just look through all these tools. There's a rich variety of data connectors here, which is what makes LlamaIndex so special. You can connect it to basically everything, and it's all community driven. That's super, super awesome. Now, what we're going to exchange here is, or first of all, we said we need to install it. So let me go to the tutorial directory again, and I'm going to do a UV add. What was it called? It was called LlamaIndex LLMs Ollama. So just copy that, UV add in my case, in your case, pip install, if you're just using the ordinary Python installation. And once we have this, we can go into our code. I hope I don't need to restart. And we can say from LlamaIndex.LLMs.Ollama import Ollama. And then I can exchange here the OpenAI with Ollama, and then model is equal to Qwen 3 0.6 billion. Now, this model is not very smart, so probably it's not going to give very reasonable answers most of the time. Let's see. Now, keep in mind, we're still using here the OpenAI embeddings for the vector store part. We're just replacing the agent itself when it answers. So now I'm going to run this again. Actually, I'm missing a comma. There you go. I'm going to run this again, and we're going to see if it knows my favorite color. Take some time. You can see now the requests are going to localhost. This one went to embeddings from OpenAI, but here now I was talking to my local model, and I get your favorite color is cyan, which is correct. It also knew that it had to call a tool. And then I can run this again here with a context, and it should say something like, yeah, that's probably not the most common color, but I know what you're talking about, which is important. And then we can see if we can also use the RAG capabilities, response, agent run, what's my favorite food. In this case here, it probably tells me result is not set. Do I need to await this? Yeah, I need to await this, of course. So I don't have access to your personal information. So let's maybe say you need to call the context tool. Then it should hopefully manage to do that if I instruct it to call the tool. Take some time, and the tools you provided don't include a function to retrieve personal information. I literally told you which function to use, so let's try. If I give you the name, maybe you can handle it then. You need to call this tool here. If it doesn't know how to do that, then yeah, I guess we're gonna stop trying. There you go. It called the tool. It called the OpenAI embedding API, but it's not the smartest model. As you can see, your favorite food is oranges, banana. Great. Yeah, so this is how you can also use Ollama. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. So the next thing I want to show you is how we can change individual components of this whole part. Now, we already did that with the LLM. I changed it from OpenAI to Ollama, but I now want to show you one more time how we can change this to Google. I want to show you how we can change the vector store to face, and I also want to show you how we can change to a specific embedding model. So we're now going to make all of this more customized. And for this, we're going to start with the installations. How do we know what we need to install? We can just go to LlamaHub. Here I can type GenAI. This is going to show me Gemini. So this is actually Google GenAI is Gemini. You can see LlamaIndex LLMs Google GenAI. This is one thing that we need to install. So let's open up a terminal, navigate to this directory again. In my case, again, uv-add, in your case, pip install this package. Then we're also going to need face, because I'm going to use face. To be precise, I'm going to use it with the CPU to keep it simple here. So face CPU, this is just a vector store. You can also use something else if you want to. And then we also need a data connector for face. So I need to go here and I can say face. There you go, face vector store. Click on this and you can see LlamaIndex vector stores face. So these are the three packages that we're going to add now, and they're installed. We can go back here, and now we're going to exchange this index with a face vector store. So I'm going to say here, first of all, from LlamaIndex LLMs.Google GenAI import Google GenAI. We're going to get rid of Ollama. We're also going to get rid of the OpenAI LLM, but we're going to use from LlamaIndex.embeddings.OpenAI. We're going to use the OpenAI embedding. So we're still going to use an embedding model from OpenAI, but we're going to use a specific one. And then I'm going to say from LlamaIndex.vectorstores.face import face vector store. And then finally, also, we're going to say import face itself. That's also going to be important. So what we're going to do now is we're going to keep the documents the same. We're going to still load them from the directory. We're also going to use vector store index, but not right away. So I'm going to get rid of that. And I'm going to also, for now, get rid of the query engine. Doesn't really matter. And now the first thing we want to do is we want to create the face storage context first, and then we want to just pass it as a parameter for the vector store index. So I'm going to say here vector store is going to be equal to face vector store, and for this we need face index, and that's going to be a face.index. Why do I not get auto completion? Okay, then I'm going to type it index flat L2, and here we're going to pass a dimensionality. So the embeddings from OpenAI are 1,536 dimensions. So that is just a format. You need to know what embedding model you're targeting. The one I'm going to use has this dimensionality in the output. And now I'm going to say storage context is equal to storage context, which of course needs to be imported here, storage context. And this storage context from defaults is going to be taking the vector store in as a keyword parameter. So vector store is equal to vector store. And this storage context now can be passed when creating the index. So we can say index is equal to vector store index. We can say actually from documents as we did before. So vector store index from documents. We can pass the documents, but we're going to also pass the storage context. So I'm going to say storage context is equal to storage context. Now we can also set the embedding model here. So I'm going to say embedding model, or actually it's embed model, that is going to be equal to OpenAI embedding, and the model name is called text-embedding-3-small. I think we should provide model is equal to here, then add some spacing here. And that is now basically the same idea as before. We can also turn this into a query engine. That is not a problem. Index as query engine. And this now works with a specific embedding model. And of course, we can use a local one. We can use Ollama embedding. We can use Gemini, whatever. And with a face vector store. And then finally, we can go down here and exchange this with a Google model. For this, by the way, you need to get an API key again. In my case, what I did is I just got this free API key from Google AI Studio. I copied it. I put it into my .env file as a second line where I said Google API key, and then I basically just put it there. So for that, of course, what I also need to do is I need to reload the environment, and I need to also import OS so I can actually access it. And here now we're going to say that Gemini, or what was it, Google Gen AI model is going to be equal to Gemini 2.0 Flash, for example. And I'm going to pass the API key, which is going to be OS get from the environment the Google API key, which I provided in the .env file. So let's see if all of this works now. I can just run this. There you go. It's using Gemini here to actually do nothing yet, but it gets the Gemini model here. We also have the embeddings used from OpenAI, and now I can run this, and the response is your favorite color is cyan. So response is equal await agent run. Is it common for people? Print response. Can it also, okay, now I already told it what to do. Of course, it's going to use the tool, but maybe I can say nothing. Maybe it can just figure that out on its own. And I'm getting a client error, I assume. Yeah, okay, there's just too many requests. This is a Google error. We're not going to talk about this now. But basically, you can see we can swap out components. I can use a different storage context, a different vector store behind the scenes. I can use a different embedding model. I can use a different reasoning model here for the agent. All of this can be used here in LlamaHub. I can just look up whatever I want to use. I can say I'm looking for a different embedding model, click on embeddings. Here I get all the embeddings. I can use different indexes. There you go, indexes. Yeah, so that's super convenient. Vector stores, same thing. We can just use a bunch of different vector stores. We have a bunch of data connectors and third-party packages. Now, finally, I want to show you two more things, and then we're going to wrap this up. I'm going to start here by showing you prompt templates. So from LlamaIndex.core.prompts, import the rich prompt template. And the idea here is just that we can have placeholders and then we can fill them. Very simple to a Ginger template. We just say here template is equal to, let's make this a multi-line string. So 3 quotation marks, and then we can say something like take the following context into consideration. Then we can have some separating lines here, whatever, something like this. You can copy it. In between, we can have now with double curly brackets a placeholder like context string. And then I can say, now answer this question, or this query, I should say. And then we can say query string. This is just a nice little thing that we can do with LlamaIndex. I can now take this, I can turn it into a prompt template, and then we can fill it. So I can say QA template is equal, or actually is equal to rich prompt template, and then template string. Or actually, I just called it template. That's going to be the template itself. And then I can just say the prompt is equal to QA template dot format. And then I can just pass context string here, and then I could say, I don't know, I like oranges, again, to stay in the same example, and then I can say query string is equal to what do I like, question mark. And then the prompt would not give us the answer, it would just be the prompt with all the stuff formatted in. Nothing too fancy, but that's one way we can do it with LlamaIndex. And then finally, a small thing that I want to show you is how to model message histories if we want to pass not just a single message, but already a message history that needs to be continued. For that, we can say from LlamaIndex.core.lm import and then chat message and message role. So the idea here is we're going to say the role can be system, assistant, or user. And we're going to say we have a model. And for that, we can say OpenAI model is going to be equal to GPT-4o mini. So now we don't have an agent, we just have a model. And what I want to do now is I want to pass a message history. So messages is equal to a list. And every entry here is going to be a chat message that has certain content and also a role. So role can be, for example, message role dot system, and the content can be you are a helpful assistant. And then I can say comma, and I can say the next role is user, the content is what is the best color, and then the assistant could answer obviously it is blue. And then we could ask as a next question, why is that question mark? And hopefully we get some answer. That is, part of this context. So we can say response is equal to model chat, and we pass the entire message history. And once this is done, we can just say print response. And here we get blue is often considered a favorite color for many people for several reasons. And we get it. So this is mainly what I wanted to cover. I wanted to show you how to work with LlamaIndex in a very basic way. If you want to go deeper into that, first of all, I want to give you a couple of links. Second of all, if you like this video, we can also make a follow-up, some advanced LlamaIndex or some advanced retrieval or RAG with LlamaIndex, because there are examples here in the documentation like advanced retrieval strategies. We have property graph indexes, we have structured hierarchical retrieval. So LlamaIndex, as I mentioned in the beginning, is very much focused on retrieval, indexes, vector stores, on data connectors, not so much on general agentic stuff, but primarily on retrieving data and working with context and working with data. So if you want to go deeper into that, you can take a look at these segments in the documentation. Or you can also let me know that you want to see a deeper dive into LlamaIndex in a more advanced crash course. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a tutoring tab and also a services tab. There you can contact me if you want to have some one-on-one tutoring, one-on-one teaching, or if you need some help with your startup, project, idea, whatever, you can contact me there and we can talk about this. You can contact me via LinkedIn and email. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video and